Welcome to Paripurna Academy. I am J. Tabital and today we are going to discuss on the topic of kinematics. So kinematics is a branch of science which deals with the mechanics. So kinematics will describes or kinematics will gives us the motion of the objects in words or by numbers, in graphical representations using equations. So this is the main purpose of the kinematics, and it will develop the sophisticated mental models of the objects which are all in motion that we are seeing in the real world. So this is the simple introduction about the kinematics, and in this session we are going to see what are scalars and vectors and three-dimensional motions. Likewise, we are going to see the projectile motion, and finally we will see some problems related on these topics. So now we will go on to the session. So what is scalars? So what are scalars? So the physical quantities which have only the magnitude and no directions are called scalars. Only have the magnitude but no directions. For example, it is mass, length, time, speed, work, power. These are all have the magnitudes but don't have the direction. In the case of vectors, so vectors are the physical quantities which have both the magnitude as well as the direction. They are called as vectors. Example: displacement, velocity, acceleration of the object, force, momentum, etc. So these vector quantities will have both the magnitude as well as the direction. Here comes the coplanar vector. So the vectors which act in the same plane are called coplanar vectors, that you can observe in the image. So they all act in the same plane. And here comes the unit vector. So a unit vector is a vector of unit magnitude which is drawn in the direction of the given vector. So a unit vector is the direction of the v vector. So it is represented as v. So it is given as u vector is equal to direction v vector divided by modulus of v vector. That can be written as 1 by modulus of v vector into v vector. So in the image you can see the unit magnitude is drawn in the direction of the given vectors. So it is called as the unit vector. Now here comes the one-dimensional motion. What is one-dimensional motion? So the motion of an object which is said to be a one-dimensional if only one of the three coordinates specifying the position of the object by changing with time. So here the object moves along a straight line, so that you can see it in the image. An object is moving along the straight line, and this motion is called the rectilinear or linear motion because it is traveling in a straight line. As shown in the figure, only the x coordinate changes from x1 to x2 when the particle moves from p1 to p2 along the straight line path. So here only one coordinate is represented. So it is called as one-dimensional motion. X is from point O to P1, the only coordinate O to P2, the only coordinate x is into 2, x1 and x2. So here only one coordinate is represented. So what are the examples of one-dimensional motion? It is the motion of a train along a straight line. So when a train goes on a straight line, it is a one-dimensional motion. Likewise, the motion of a freely falling body. So when a particular height, when we drop a object, it is also will have a linear momentum, that is one-dimensional motion. Now here comes two-dimensional motion. The motion of an object is said to be two-dimensional when only two of the three coordinates specifying its position changing with the time. So in one-dimensional only one object, in two-dimensional here only two coordinates are specifying the position changes by the object due to the time. Hence an object moving along a plane as in the figure the coordinates x1, x2 changes to x2, y2 as the particle moves from P1 to P2 in a plane. So that you can observe it in the image. From point P1 to P2 there are two coordinates x1 and x2 in the x-axis, y1 and y2 in the y-axis. So there are two coordinates are represented in the two-dimensional motion. So the examples of two-dimensional motion is nothing but motion of the planets around the sun. So the planets revolving around the sun is the two-dimensional motion. Likewise, when a car moving along a zigzag path on a level road, that is also an example of two-dimensional motion. Now here comes three-dimensional motion. So the motion of an object, if it is a three-dimensional, means all the three coordinates will specify the position of the object with change of time. So here in the object moves in the space, three-dimensional motion, they have given the object is moving in the space, and as in the image we can see the coordinates x1, y1, z1 changes to x2, y2, z2 as the particle moves from P1 to P2 in the space. So you can observe it in the image, from the point x it is x1 and x2, and next they moves to x1, y1, z1 from x1, y1, z1 from point 1 it changes to x2, y2, z2 in the point P2. Then what are the examples of three-dimensional motion? A kite flying on a windy day. So during the windy season the kite will fly on the sky. So it is due to the three-dimensional motion. Likewise, the motion of the aeroplane in the space, it is also moving under the principle of this three-dimensional motion. Now here we are going to see relative velocity. So the relative velocity of an object A with respect to object B, when both are in motion, it is the rate of change of position of the object A with respect to object B. This is the relative velocity. Now, if the two objects are moving with the velocities, then V vector AB, two objects AB is equal to V vector A minus V vector B. The relative velocity of A with respect to B will be, how we can intimate that? That is VAB is equal to VA minus VB vector. Likewise, with respect to, that is the relative velocity of the B with respect to A means VBA is equal to VB minus VA vector. So these are the relative velocities. Then VAB is equal to root of modulus of VA vector square plus and minus of VB square plus 2 VA into minus VB and cos 180 degree minus theta. Then when we simplify, what we will get? This is the formula. So root of VA square plus VB square minus 2 VA VB cos theta, A square plus B square minus 2AB. So if the velocity of V vector AB makes the angle beta with the velocity of VA, then tan beta is equal to modulus of minus VB vector into sin 180 degree minus theta, which is divided by modulus of VA plus modulus of minus VB into cos 180 degree minus theta. So that will gives us VB sin theta divided by VA minus VB cos theta. So this is the relative velocity.